Alright, everybody, welcome to the Math Hive, where it is my goal and passion to teach you a wide range of topics in the field of math. Today, we're going to be talking about arc length for the SAT. So, when we talk about an arc, we're talking about a specific portion of a curve, specifically that curve being around the circle. So, when we're talking about an arc length, we might be talking about this length right here of the circle. Maybe we're talking about the whole circle, maybe we're talking about this length right here, but we're usually going around the circumference of the circle. Those are our arcs, our curves, and we're trying to figure out those lengths. So I want you to think about the arc length of the whole circle. You go all the way around. What do we call that? We call that circumference, right? Our circumference, we'll call it c. It's equal to 2 times pi times the radius, where our radius is from the center out to here, right? So this is how we would find the arc length of the entire circle. But let's say we wanted to figure out half of the arc length of the circle. Well, intuitively you're thinking, well, we would just take half of the circumference. But what necessarily identifies half? How do we know we're at the halfway point? Well, we could go all the way around the circle, and we know where to be at to come make a full circle, so we go halfway through that. And another way of determining this is by angle. Imagine a full circle where you go around the whole thing, you've gone 360 degrees. But when you've only gone through half of the circumference, you've gone half the angle, you've gone 180 degrees. So 180 degrees correlates to half the circumference. Half of the angle is half of the arc length. So naturally you might think for a quarter of the angle, so 90 degrees, well, it's a quarter of the arc length, and if you look at it, it makes sense, right? This looks like a quarter of the whole thing. So that means arc length and angle are proportional. If we know the angle, we can figure out whatever the arc length is. So let's come up with a formula for that. So I've started the formula a bit over here. We have that our arc length is equal to our circumference, right, the whole thing, times something. Well, it's whatever proportion of the angle you have. If you have the whole angle, you have the whole circumference. If you have half of the angle, if you have half of 360, which is 180, you have half of the circumference. If you have a quarter of the angle, you have a quarter of 360, you have a quarter of the circumference. So it's whatever our angle is in degrees divided by the whole amount of angle, which is 360 degrees in a circle. And then of course we know that our circumference is equal to this right here. So we know that our arc length is 2 pi r times our angle over 360. And of course this is when our angle is in degrees. So I want us to try out using our arc length formula on this circle right here. So we know that our arc length is the whole circumference times whatever portion of the angle you have. So, and we derived a formula for that, this thing right over here. So now it's just a matter of plugging in. What is the arc length made by the points A and C? We just have to plug in 72 degrees over here. So it ends up being that arc length is equal to 2 times pi. Well, we know our radius right here, it's 8 inches, times 72 over 360, which is equal to 16 pi. And if you can do the fraction pretty quickly, it's actually 1/5. And then this is equal to 16/5 pi. This is what it is without putting in the calculator and actually multiplying this by 3.14. We're just leaving it as a fraction with pi. So that would be the length of this entire sector of this arc right here. So I'm sure many of you have heard of radians before, used with degrees, and it's really just another way of measuring angles. For this angle right here, we might call it 60 degrees, but we could also call this pi over 3 radians. And both of them are angle measures that we use all the time in math. In a later video, I'm going to go more over why people want to use radians, like where did it come from, what are its uses, how good does it work. But many of the arc length questions they're going to ask you are going to be with radians. So we need to know how to go from degrees to radians and how to go from radians to degrees, because that may be something that we need to do, which I'll just go over really quickly. So when we have a degree, what we have to do is multiply it by pi over 180, and we get our radian. Vice versa, if you want to get degrees from radians, you would take your radian, multiply it by 180 over pi, and you would get your degrees. So these are just the conversions that we can use to go from radians to degrees. Now let's apply this to our arc length formula. So if we take a look at this equation here, we're using degrees, but I want to create a new equation where I am using radians. Well, I know that a degree is equal to a radian times 180 over pi. So if I can substitute that in, then I'll be able to figure out what our arc length formula is using radians instead. So I labeled this as RA as to not be confused with radius. Radian and radius are two different things. And now we're going to do a little bit of math to help us cancel out all the things over here. So if you notice, this pi and this pi cancel out. 2 times 180 divided by 360 is just 1. So this means that it's just our radius times our radian. This is what arc length is equal to. And a more common form that you will see is that arc length is equal to radius times your angle in radians. This is a more common form that you'll see. But you can see here how using radians can benefit us a lot, because if we have our angle measure in radians, all we have to do is just multiply that by our radius and we get our arc length. So I have here a fairly easy arc length question that we can do, but this is just so we can put our fundamental understanding of arc length in practice. In the circle above the segment AB is a diameter, and if the arc length of ADB is 8 pi, so that's just saying going from A to D to B, if this arc length is 8 pi, what is the length of the radius of the circle? So we can think about this in both intuitively. You might not even need to know arc length to sort of guess what this answer is, but we're going to use it anyway. So we know that our arc length is some portion of our circumference, right? And in this case, it's made by this angle here. So this angle right here, well, it's a flat line. We know this angle to be 180 degrees. And then of course, it is out of the whole circle, which is 360 degrees. So in other words, it's just our 2 pi r times 1/2. And the 2 and the 1/2 cancel. So our arc length here is really just pi r. And they gave us our arc length. This arc length is 8 pi. And then of course, we can cancel out the pi, and we get that our radius is 8, which is answer C. So I hope you guys like this video. I will be going over some more arc length problems in a later video, where we'll be going over more SAT, problems and different levels of difficulty. If you have any questions, feedback, or any other video ideas that you would like to see, please do let me know in the comments. Thank you for watching.